Hello, my name is Eugene Tarasyuk, and today I'll be showing you guys how to do question number 2 of the free response section portion of the AP Calculus AB exam from 2010. In this problem, we have a data table, and we have t labeled in hours from 0 to 8, and e to the t, which is in hundreds of entries. And the prompt says, a zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposit entries in a special box between noon t equals 0 and 8 p.m. t equals 8. The number of entries in the box t hours after noon is modeled by the differential function e from between 0 and 8. The values of e to the t, hundreds of entries in various times t, is shown in the table above. And for part A, we need to use the data table above to approximate the rate in hundreds of entries per hour at which entries are being held positive at t. Show the computations that lead to your answer. Alright, so in this problem, we're going to need to approximate the rate, which means we need to find the slope. And this problem is going to be answered in hundreds of entries per hour. And we're looking for t equals 6, which is not given, but it will be right here. And to find that, we would need to do e of 7 minus e of 5 divided by 7 minus 5, which would be 21 minus 13 divided by 5 minus 7, which is 4. And remember, the answer will be in hundreds of entries per hour. So we have the answer is 400 entries per hour, and that is worth 1 point for the answer. In part B, we're going to need to use a trapezoidal sum with 4 subintervals given by the table to approximate the value of 1/8 integral from 0 to 8 dt. And we'll also need to use correct units in explaining the meaning of it in terms of numbers of entries. Alright, so here I did the work, and we have 1/8, and the integral from 0 to 8 et dt is right here going to be the height, which is the difference between the times. We go from 0 to 2, and then we're going to divide it by 2 because that's how we find the average. And we do the same thing for the rest of the intervals. So we go from 0 to 2, from 2 to 5, from 5 to 7, and then from 7 to 8. This is also a calculator problem, so I entered it into my calculator. You got to make sure to put all your parentheses so you would get the correct number. And this is what I got. I got 10.6875. But I just rounded up to 10.688. And then for the second part of the problem, they ask you to explain what that means. So what it means is the average number of hundreds of entries in the box that were entered between noon and 8 p.m. And you would get 1 point for all of this for having the trapezoidal sum. You get 1 point for the approximation, and you get 1 point for the meaning. Okay, for part C, it says at 8 p.m. volunteers begin to process entries. They process the entries at the rate modeled by the function p, where p of t is equal to t cubed minus 30t squared plus 298t minus 976. Hundreds of entries per hour between 8 and 12. According to the model, how many entries have not yet been processed by midnight? T equals 12. To find that, we're going to need to have the final number of entries. There was 2,300 entries, so we have 23, and you're going to subtract the integral from 8 to 12 of p of t dt, which is 23 minus the integral from 8 to 12 of t cubed minus 30t squared plus 298t minus 976 dt. So you get 23 minus 16 equals 7, and it's in hundreds of entries, so you get 700 entries. And for this, you get 1 point for having this integral and 1 point for the answer. And then question D says, according to the model from part C, at what time were the entries being processed most quickly? Justify your answer. To get that, you would need to find the derivative of p of t and set it equal to 0. And you would get this. How I did that was go on your calculator and you could put in the original function and put in the derivative. And the blue one is the original function, the red one is the derivative. And then you press second calc and you find the zeros. And where the zeros are, that's where p prime of t equals 0. So right here we have one of them. It's at 9.1835034, and the second one will be at 10.816497. But for this problem, you also have to include the endpoints 8 and 12, and then you go into the table function of the calculator, and you just graph the endpoints and where p prime of t equals 0. And the maximum occurs at t equals 12, which is the highest number is 8. So t equals 12 is the maximum. So that means that entries were being processed most quickly at t equals 12, which is at midnight. And for this problem, you get 1 point for considering p of t equals 0. You get 1 point for identifying all the candidates, all the 4 candidates. And you get 1 point for answer and justification. So 1 point for all of this. Alright, and that's it.